Hello, my name is Alexey Malanov. I am a smart contract auditor at Certic. In this chapter, we will talk about Ton smart contract security. Ton is an innovative blockchain that incorporates novel concepts in smart contract design. However, the development of smart contracts still requires accuracy. In addition to the traditional aspects of security and attacks, new ones are added that are unique to Ton. Let's discuss them. In this chapter, we will talk about the external messages. As you probably already know, Ton smart contracts have 3 possible entry points. Every contract must have a function redsv internal. Optional redsv external is for inbound external messages. And run TikTok is called in TikTok transactions of special smart contracts, not used by regular contracts. Here we will talk about redsv external. The concept is familiar. The user makes a transaction off-chain, usually signs it with their private key and sends it to the contract. A wallet in Ton is just a smart contract. Let's write a naive wallet. It only forwards the messages signed with our private key. The basic implementation looks like this. Here we can see the contract. What we do, we read the signature from the incoming message, make a copy of the incoming message, reading the content storage. A wallet in Ton is just a smart contract. Let's write a naive wallet. It only forwards the messages signed with our private key, and the basic implementation will look like this. First, we read the signature from the incoming message, then we make a copy of the incoming message. Then we're reading the contract storage. We read the authorized key. We check the signature. And at this moment, we are ready to pay for gas and process this transaction. Then we read the mode from the incoming message and send the provided message. Here it is. Indeed, this contract will process the message signed by the contract owner. But nothing prevents malicious parties from reading the payload and retransmitting. This is known as a replay attack. I repeat, the attacker gets the message signed by the contract owner and sends it again to the wallet. It will be executed again. Wallet owner now needs to supply a sequence number that's incremented over the stored one. This ensures any message can be processed only once. So we changed one line regarding reading the input arguments. We changed another line that loads the contract storage. And now we added the check that message sequence number is equal to the storage sequence number. We also added the storage updating here. The storage sequence number is incremented after each message processing. redsv external should be used carefully and accept messages only after verification. Otherwise, gas could deplete the contract funds with gas-free malicious execution. Let's take a look at the code. Here, we first check the signature and other arguments, and only after that we accept the message. Also notice that the same signed message can be replayed on another wallet of the same owner. Or message in testnet can be replayed at mainnet. Note that if after accept message some error is thrown, transaction will be written to the blockchain and fees will be deducted from the contract balance. But storage will not be updated and actions will not be applied as in any transaction with an error exit code. As a result, if the contract accepts an external message and then throws an exception due to an error in the message data or sending an incorrectly serialized message, it will pay for processing, but have no way of preventing message replay. The same message will be accepted by the contract over and over until it consumes the entire balance. That's why we will save the updated state before the message parsing and execution. Let's take a look at the updated code. First, we have moved the block with storage saving up, and we are committing it to the storage right after the block, because the next 2 lines with mode parsing and sending the message can actually fail. In Ethereum virtual machine, replay protection goes out of the box. First, the private key has only one associated address. Then, nonce is automatically increased after each processed transaction. And also, wallet owner pays for gas and failed transaction can't be replayed. Ton is more flexible. One private key can control many wallets. Wallet can have any logic coded, and external transaction is credited with 10,000 gas. If accepted, it will spend the contract balance. Luckily, there is a simple recommendation for most of the contract developers. Avoid processing of external messages. Let the wallet contract do this job. Have only reds internal in your contract. Even if you are writing a multi-sig or special wallet, you can still process only internal messages from regular wallets. You will get EVM-style transactions in this case with all the flexibility under the hood.